Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about myths and pitfalls of planning and scheduling, and it's brought to you as a part of Mobius Connect's ongoing YouTube series, Connect Conversations. I'm Kim Fugger, the manager of Mobius Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce the host of Connect Conversations series, Global Reliability Improvement experts Ron Moore, Gary Tyne, and Andrew Frazier. How are you guys?
Good, thank you.
Doing well. And before I officially pass it over to you, I just want to encourage anyone in our audience today to submit any questions through the chat function to Ron, all of us as a panel or myself, and they will be more than happy to take time out today to answer your questions on air. Again, your questions will be aired anonymously, so no need to feel like you're getting called out. And all three of them are here to provide their advice and perspectives from their experiences and are here to help you. All right, guys, go ahead and take it away.
Okay, thank you, Kim. And thank you guys for showing up. We're going to talk about, as Kim said, the myths and pitfalls of planning and scheduling. So as usual, I'm going to start out with a few comments and I'm going to direct it over to Gary and Andrew for their input, and then we'll just take it from there. I've got a bunch of stuff that I could touch on, but we'll see if we just cover it automatically. The myth or the pitfall in most of these systems is that, if I have a complete asset registry, if I've done a criticality analysis, if I've done my PM setup and got them and all my plans and loaded them into the database, if my calibration schedules are loaded, and if I've got all my OEM manuals, drawings, and so on, and I've got my CMMS linked to spares and to some sort of condition monitoring program, and linked to cost accounting. Anyways, and I've got a prioritization process that everybody understands in place. It's a category 1 or category 5 or whatever. And then you've got emergency versus, a month from now or 6 months from now. So if I do all that, then, my maintenance planning and scheduling will improve, and, my efficiency will improve, and stores can be minimized, costs will come down, availability goes up, reliability improves, and everybody's happy. Well, maybe not. So with that, let's talk about all those, shopping list of stuff that you really need to do in order to make a CMMS and your planning and scheduling work management process work effectively. So with that, and I don't know if you guys were taking notes, I can repeat some of that if you want. So with that, Andrew or Gary, just jump in there.
Yeah, I mean, for me, Ron, that's a nice shopping list that you have just read out. I do think, though, that there is often the CMMS isn't the be all and end all for planning and scheduling. I think there's got to be. I think sometimes I see one of the pitfalls is companies purchase a CMMS and think that is going to fix everything for them in terms of maintenance management. There's got to be a structure in place for planning and scheduling within the CMMS. Planning and scheduling are just two components. There are other components that are needed to be in place, and the CMMS is just the tool that enables the planning and scheduling to go ahead.
One analogy that seems to work pretty well is it's like buying Word and expecting that you can write a novel.
Yes.
How that's supposed to work. Anyways, Andrew, any other additional comments?
No, just adding to what Gary said. I think it's that part of it has to be looked at, I think, in terms of a fully integrated work management system. with the planning and scheduling components, and the CMS is a tool in that sort of process. But it's all that with KPIs, etc., that sit around that to measure how well the system's working. So yeah, in terms of that, as an opening part, Ron, you're talking about this as really sort of theory. In theory, that should work, but I guess what we're going to come on to in a moment is the reasons why that might not work.
Yeah, well, it might not work because, well, you don't do that. You don't finish that shopping list. You haven't done a criticality. You haven't loaded. Your PMs say things like check motor or check belts or check coupling or whatever, which isn't really a PM, as we've discussed in the past. It's just a hope, or, all kinds of things. One of the comments I would give you, though, is this, and I say this quite a bit when I'm out there, doing my workshops and so on. And that is, if the total number of defects overwhelm the maintenance planning and scheduling system, it is doomed to failure. You can work really hard at putting plans together and schedule them and so on, but if every day you come in and there's pop-up work that showed up last night, and you take all that work you've got in your planning and scheduling, you say, well, never mind that, we're going to do this today because it happened last night. That's when the defects are really overwhelming your ability to actually apply a CMMS. So let me bounce it back to you guys. Any comments relative to that?
Andrew, do you want to go?
Yeah, no, that's absolutely true. I think some of that, I've seen situations where there's been where the sort of weekly maintenance plan or schedule has been interrupted, but sometimes without sort of full sort of justification in terms of the prioritization of the work that we mentioned in a previous workshop. Been working one particular director who is has a very strong view that it's been their weekly maintenance schedule has been interrupted too many times without that necessary justification. And one way of addressing that is to raise the authority level in which and when who can actually break the weekly maintenance schedule to try and stream out quite a bit of that. But you're absolutely right. The fundamental point is, if you've got that much work coming in and it's all seen as urgent, then what's in the plan, what's in the schedule for that particular week is likely to not get done.
Yeah. But and the other thing too is they're kind of related, at least in my mind, it's related, is that I think the production plan and the maintenance plan need to be integrated into one plan. And if they're not, what very often happens is production says, oh, no, this is more important than that. And so all the planning that you put in place becomes kind of, well, here's what we suggest for the day. What do you think? And then that winds up being, merely a suggestion as opposed to, something that's really more solid that you can plan on doing most of the work that's in there. So any comments or on that point I just made?
Gary?
Yeah, I mean, go on, Andrew.
No, I knew you were ready to speak. Then just carry on.
Yeah, no, I was just going to say going back to the defects, the number of defects coming in the system. I've always been that great believer. Yeah, you've got to have your maintenance plan for next week, for the following week. I'd always like to have it locked down on a Thursday of the week before, and that any defects that do come into the system the following week are based on criticality of the assets and the priority across the facility. Is about, they have to be managed. But there's one thing I do come across quite a lot is where defects are being raised but aren't breaking into the plan this week, and it's something that we can actually fix the following week. But when that work gets raised in the maintenance plan, it becomes a planned maintenance activity, when actually what it was a breakdown, And I think sometimes the definition of a breakdown is not understood very well within the planning and scheduling process. And sometimes breakdowns that then get planned to be fixed end up taking the KPIs. We look good on paper because we've got all of this planned maintenance, but when you look under the hood,
The bonnet, yeah.
the bonnet,
The hood, the hood,
the hood.
the
Don't
hood.
forget, Andrew, it's
Yeah,
the hood.
You're right.
Yeah, when
Depends
you
what
look
you
under the
are.
teach
hood,
people to speak English here, you know, not American.
yeah, but you start lifting up the hood and you start having a look, and actually what you're finding is all of these defects were actually breakdowns, and we didn't know that they were going to happen. So yeah, managing defects and how we record them, and what we record them as is very important to be able to give us some meaningful data moving forward.
One thing you might do relative to that is tag it differently, name it differently. You know, it might be planned corrective or planned breakdown work as
Yeah.
opposed to planned work, you know, just to differentiate. So
And
that might be a category for you.
yeah, and that's probably another topic within planning and scheduling, Ron, is the number of work order types. Quite often I've gone into organization and they've got like 15, 18 work order types, and nobody really fully understands what those work order types mean. And really, at the end of the day, there's just too many, and it just muddies the water.
Well, I've been I was at a refinery once where they had 125.
Wow.
And
Wow.
nobody cared.
No.
Who could remember under 25?
Wow.
And they were using, I think they were using maybe 10, you know, but 5 amounted to 95 or whatever percent of the work. So, you know, narrow your focus, guys, and
Yeah.
then, you know, do it that way. And another thing that I see happening is quite often is it's not resourced appropriately. You know, if you believe some of the benchmark data, you need one planner for every 15, 20 maintenance technicians. Now you have to count contractors too, because their work has to be incorporated in your plans. And very often people don't have that. Or very often a planner isn't really a planner. It depends on the day. You know, if they've had an emergency the night before and they've only got, you know, 1 or 2 or 3 electricians and one of them's sick and the other one's in training, well, you know, the planner becomes electrician that day. So they're not adequately staffed to do that. One of the best plants I was ever at won the North American Maintenance Excellence Award. They had one planner for every 12 maintenance technicians. And the point there being, you want the planner to make the efficiency of the techs. You know, you want them to be more productive. So you could, you know, I've got a little math example where you could have 3 guys doing all reactive and they're about 35%, 30, even 25% tool time productivity. You make one a planner and it goes to 55. Well, that means that one planner for every 2 technicians actually gives you better productivity. And I'm not suggesting you have one planner for every 2 technicians. That's not the point. The point is don't scrimp. Use that effectively to make, you know, the other, whatever it is, 10, 20 guys much more productive. And that way, you know, life gets better for you. So anyways, I'll pause
I
there.
think, yeah, and I think just aligning with that is that the planning role in these sort of high performing plants is looking ahead to the following week or the week after that. It's not planning for the next day. That's
right.
You know, that's not a good use of a planner's skill to do, you know, to do that type of activity.
Well, you may have to on occasion, you know, when you have a bona fide emergency where you just quickly pull together, you know, the equipment file and maybe a few resources and give them a head start. And then you go back after and revisit it and put it in the equipment file so that it's there if it ever happens again. So yeah, you know, I agree with that. That those kind of jobs are not planned in the traditional sense. So anyways, now what, in your view, and you know, I've got my own view, but I want to ask your view, what are the characteristics of a good planner? You know, if you were hiring a planner, what would they have as their basic, you know, employment characteristics?
I think, well, I'll kick off with one. I think having experience of the equipment, the equipment type, and having experience of the work that's being done would be one of the things for me. So and that lends credibility of the planner with the other technicians as well when it comes to the planning and the scheduling of the work.
Okay.
Yeah. I would say having a good understanding of the CMMS, the computer maintenance management system that they're going to be working in, and having some IT capability as well. I have come across planners they've been made a planner and haven't actually used computers in the past. So I think that's a skill that can be trained. It can be trained. But I think I would be looking for some level of IT skill.
Yep. Okay. Well, I'll throw one in there. They have to be reasonably intelligent, you know, because they're going to be dealing with quite a bit of complexity with, you know, interfacing with stores, interfacing with cost accounting, interfacing with the technicians and all that sort of thing. So they have to have that in. What else do you think?
I think specifically related to that is a degree of organizational skills. Putting someone in the role who's just got the experience of the equipment but doesn't have that forward planning and coordination type of skill, or at least have the potential to have that developed, would probably not be well, the reverse of that. You have to have that, I think, to be a good planner.
Yeah. And maybe the last one or another one, you guys throw in, you know, whatever you think's appropriate is. I would be looking for a friendly guy that gets along with most folks and is able to manage different personalities that he or she is going to come across in terms of, you know, trying to manage the interface with production, trying to manage the interface with the maintenance manager, trying to, you know, deal with the technicians and so on. So they, you know, they have to be a fairly easy to get along with kind of person, while still maintaining all those other capabilities. So it's not a job, I don't think, that you would just throw anybody into it and expect them, you know, to be able to do it well. You know, they have to be experienced, they have to be intelligent, they have to be able to deal with complexity, they have to be relatively friendly and easy to get along with, you know, perhaps among other things.
Yeah.
Anything else to add to that, guys?
I would probably just add to that, Ron, that there does need to be a job description for the planner so that the planner knows what is actually expected of him or her. You know, without a clearly defined role, I see planners just doing scheduling, and actually the job isn't being planned. They just do scheduling of the work. So I think a clearly defined job description for a planner and a scheduler is important, and that they understand what their job is, and they don't go into the role thinking they know what it is. That it has to be clear. It has to be clear to them.
Yeah, and other people around them as well understand what that role is for. Otherwise, this resource can become a valuable resource to get other things done.
That's right.
Detract from the less urgent work that the planner's role is really there to do, make sure that's done effectively.
Yeah. You know, just it was back in 2021. I actually facilitated. We started with a root cause analysis, and it was called the Workflow Management Review. And out of that, we identified 81 causes, 9 root causes and 12 solutions how to improve the maintenance workflow management because it wasn't being executed very well. And one of the things we actually performed was a day in the life of a planner, because the planner was, it became obvious as we were doing the root cause analysis that the planner wasn't doing much planning. And when we actually broke it down into his and it was a young gentleman, into his activities, 67% of his activities in the week were not related to planning.
Yeah. And it kind of related to that, I think there's another issue, and that is the organizational structure has to facilitate and encourage and support, proper planning. And particularly in big organizations, small organizations, you have to maybe do multitasking and all that sort of thing. But big organizations where you have 5 planners, I think those guys should report to a planning supervisor and not report to each individual area for their, day-to-day direction and, developing scope and all that sort of thing. Because if you do that, you're going to get inconsistency in the planning process. You're going to get guys reassigned to find parts or reassigned to do actual, maintenance work or whatever it is. So, having that, now they might be assigned to an area where they get familiar with the crews and the equipment and all that sort of thing. But I don't think they should be under the direct supervision of the area maintenance manager or superintendent or whatever you might call him, because that lends itself to a lot of inconsistency in the planning and scheduling process.
I think that that's a really good point, particularly when there's a high level of reactivity in the plants where the discipline of planning and scheduling isn't inherent in the organization. So to have that sort of that centralization of that function, but deployed in the areas, as you say, I think is a really good point to bring some rigor and some structure and some accountability to ensure, Gary's point, that the planner's doing the advanced planning activity.
Yeah. Now, a couple other points I want to make while we're on this. One of them, the criticality analysis. We all agree, criticality analysis is really important. But I've got some data. In fact, Andrew, I think I got this from you. So on a criticality analysis that was done as a part of the plant design and startup process, and it showed one, kind of like a Pareto chart of most critical to least critical. But when they actually started operating the plant and they looked at where the most losses were, the losses didn't line up at all with a criticality analysis. In fact, let's see, I'll just look here. 9 elements. The most losses occurred in element number 7, almost the lowest criticality ranking, but you wound up with, the most losses, and number 8 was number 2, 8 in the queue of criticality was number 2 in the losses. And then it sort of goes from there. So there was no correlation whatsoever between actual production losses and the criticality analysis. Any comments on that? Do you remember that, Andrew?
Vaguely.
Vaguely. But it's been 25 years.
Is it? I mean, was it related? I mean, you could look at it a couple of ways, couldn't you? Was it related because they were doing a really good job at managing that highly critical stuff, and had taken their eye off the ball where there was perhaps more capacity available, and practices had been allowed to not develop, and or bad practices had been introduced? Was that your?
That's my personal opinion of what happened. You give
a
lot of energy to the really critical stuff and you ignore the rest of it, and then the rest of it comes up, rears its ugly head and bites you where you don't want to be bitten.
Yeah.
But it should be. I mean, for me, having facilitated quite a number of criticality analysis and studies, and done the ABC rankings and the 1, 2, 3s, and if you've ranked something as being a low critical asset, then I would be looking into that to make sure that if we do have a failure, that it isn't going to impact production, and that what's important, if you are going to agree that that item is a run to failure asset, that we have the right spares available ready for when it fails. But we are very clear that if it is at the lowest end of our criticality ranking, that when that fails, it won't have any impact on production. So I would then question the rankings that were assigned in that example.
Well, it was a MICA, failure modes, effects, and criticality analysis, kind of all thrown in one bucket. And
Right. Okay.
that's what happened. You know, maybe they didn't consider production. I wasn't there for the details of what they actually did.
Yeah.
But the broader point here is that with your criticality analysis, you know, try to make sure two things, I guess. Try to make sure that, you know, you don't wind up in a situation where your criticality analysis ignored some key issues in the plant.
Right.
And whether that's environmental or production or whatever, it has to accommodate that, or at least consider it, you know. And the second thing is, and this is kind of a philosophical issue, you can't live in two worlds. You know, one world where you care deeply about this set of equipment, and the other one where you don't give a damn about the other set, because you can't live in two worlds. So, and you have to care to some extent about all of it and have appropriate level of what reliability built in, and then operating and maintenance practices built in. So if you don't have any more on that, I want to discuss just a bit PMs, you know, and PMs, let's assume they're loaded, which very often they are not, but let's assume they are. But your PMs should consider failure modes and consequences, and should try to avoid things like, you know, check motor, check belts, and so on. Well, what are you checking? What's the objective criteria that tells you if a defect is present or an absent, or you've entered the potential failure, you know, section of the PF curve? And so that needs to be taken into account. Now, you know, I've got some data, and you guys are familiar with it, I think, where vendor PMs, you know, about a third of them are spot on, which means the other 2/3 aren't, right? So you could do them less often. You might have to do them, some of them, a few of them more often. They tend to over recommend, you know, vendors do, because that's where their money is. And the other issue is they don't understand, you know, how you operate your equipment. So I could have two identical, you know, pieces of equipment, machines. One is in this operating environment, which is hostile and aggressive and, you know, running 100% of the time, and another one is on standby. Well, those are two different, you know, PM regimes for the same equipment. So that becomes important. And the second thing is, you know, John Schultz, he looked at 20,000 PMs. He concluded about 10% of them were right, which means 90% of them are wrong.
And that was for existing plant, existing PMs.
Yeah, for existing plant. Yeah, not vendor.
Yeah.
And so you look at that kind of data, and let's assume there's a little bit of bias in the data, because, you know, maybe this guy's trying to make a point about one thing or another, right? But even if the data is only half right, you know, it's pretty important to you, you know? So, and, you know, what John concluded is that a lot of these time-based PMs, you should probably make them condition-based, you know, because on, you know, time-based stuff, as we know from, what was it, the B-24 bombers and the Waddington effect?
Liberator bombers, yeah.
A lot of the time-based intrusive PM, all it does is disrupt the system and restart the infant mortality risk. So we want to be doing, you know, probably more condition-based and, you know, less, you know, time-based intrusive, right? Time-based, you know, inspections and checks and monitoring and filter changes and all that sort of thing. That's all good stuff. time-based intrusive, I'd be
Yeah.
very suspect of it. By and large, not particularly good. So the PMs may be actually inducing more defects than they're eliminating, which in turn has a huge impact on your planning and scheduling process. So I'll pause there. Comments?
Well, even the existing PMs, they will have originally become will have come from, in most cases, when there was new equipment recommendations from suppliers.
Right.
And in particular for older plants, they may well just, a lot of it might just be based on time, because considering failure modes and effects analysis was something that is unlikely to have been done at that point. And even now for existing recommendations, one of the opportunities here for companies is to challenge vendors to produce their failure modes and effects analysis of their new equipment to justify their recommendations on PM, and also to help you manage it from an operations and maintenance perspective, to actually manage that equipment so more effectively. And another thing I've seen happen directly in organizations, this was in one particular example, is a pharmaceutical company where the plant management were beginning to become a bit more focused on reliability as a whole. And one of their initial practices was anytime they had a failure, they would start to talk about the failure at a weekly meeting and review the failure. But one of the typical questions that the production management would ask of the maintenance manager was, have we got a PM for that? Why have we not got a PM for that? And that was the limit of their understanding or their education in terms of reliability. And over time, the maintenance manager sort of acquiesced and put PMs in place because of the pressure he was getting from production. And of course, you could introduce another invasive PM that actually, as you say, restarts the infant mortality thing again. So there's I've seen that live, but I've been in the meeting when that actually happened. And so that's a source of generation of industrial self-harm activities that's taken place, and probably takes place in more companies than we probably suspect takes place in.
Yeah, particularly when the production site manager or even maintenance manager don't really understand that, you try to avoid intrusive PM and you try to go with condition-based and basic care and operator care, as opposed to, ripping something apart periodically. They don't really have an appreciation for that.
And they don't have an appreciation that the problem may well have been caused by the operators in the first place. So it's just that right. Lack of understanding of all the different sources of defects and where they can actually come from. So, but that's just wanted to illustrate as an example. We get a lot of invaluable and harmful PMs that come from the original vendors, but a lot of it is generated on the go by a lack of understanding of reliability and where the defects come from.
Yeah. And as you guys know, the reliability process that I reckon we all three use is, design, so for life cycle cost, eliminate defects; buy for total cost of ownership, eliminate defects; store for like a business, eliminate defects; install, startup, eliminate defects; operate, eliminate defects; and maintain. And maintenance doesn't really control most of those defects. They're coming from upstream. So there has to be some connection. If you're going to make planning and scheduling effective, you have to stop the defects, not just from maintenance, some of the things we've been talking about, but also from upstream that are inducing more defects. Because if you have fewer defects, you don't have to detect them. You don't have to fix things unnecessarily. And so that, drives or should drive a collaborative relationship across that chain of functions. And very often it does not. Too often they operate in their own little silo. And, if you just do your job, we wouldn't have these problems. Well, that's not how things actually go in a complex system. Everybody has a role to play and a contribution to make. And so there needs to be, teamwork, collaboration, cooperation, all that sort of thing, with the idea of eliminating the defects or the problems that are creating all these issues and lost production and extra costs. So any comments on that? And I've got a couple other things I want to touch on.
Just one thing on the vendors and the PMs. Agreed with everything Andrew just mentioned, but there's one thing we're starting to see is a reliance on vendors coming in to perform what are called the service level agreements. So the SLAs, and they will come in every 6 months and every 12 months, and they'll come in onto site. They'll go and perform some maintenance that comes out on a work order, and it will just simply say 6 monthly SLA and the contractor's name. When you challenge the customer who owns the equipment, what are the vendors actually doing on your equipment? Nobody knows. They're coming in, they need the lockout tag out, the permits, and then the vendor goes onto site and performs some activities. And yet the customer who owns the equipment are not fully aware of what maintenance tasks are being performed. And it really is it's almost naive of the customers to be allowing that to happen. If it's my equipment, I want to know exactly what is being performed, and be in control of that.
and that it's adding value.
Adding value. Yeah, absolutely.
Well, that service provider may have the same level of incompetence that you have.
Absolutely.
So they're not adding a whole lot of value if they don't, have reliability, defect elimination, all that sort of thing, precision. The list is fairly long. Now,
I don't think Ron was being personal there, Gary. So
no, I know he wasn't.
Just take think that. Yeah, just take that.
Yeah. Thanks for that.
You're one of the good guys, or you wouldn't be sitting here. Okay.
Well, that's good to know.
So, anyways, Winston Leday has recommended this, and I want to echo it as well. And that is have 1% of your work orders for improvement and defect elimination. Just to do an example, you're walking through the plant and you see a hydraulic leak, or you see a pressure gauge that's busted, or you see a sight glass that's cracked, or you see, a belt that's floppy, right? Now, none of these demand immediate attention, but left to themselves, they will eventually create an emergency for you. So you ought to just start keeping a little list of defects that the next time you work on that machine or in that area, you're going to attend to that. And if you do that, at least according to Winston's data, in 3 years, you'll cut the number of defects by 35, 40%. Well, suppose it's only 20%. Well, so what? It's huge.
Right.
So, and it might even be more than that. So, having, something on the order of 1% of your work orders for defect elimination and keeping a list of those defects for each equipment file that you pull the next time you plan work in that area for that equipment, I think is really, really, important as a part of your planning process.
Sorry, Ron, just to underscore that, I think the important thing about that with Winston is that, just in case anybody gets the wrong impression, it's not just about fixing that oil leak at the time, it's fixing the cause of the oil leak so the oil leak doesn't come back to bite you again. And there is, when we talk about defects, sometimes some people use work orders and defects almost synonymously. What we're talking about defect elimination here is removing the work so the work doesn't come back to get you again. And that's the value, I think, of the 1% stuff.
Right. Yeah, of course. Now, a few other comments. Planning and scheduling, they're not the same. Planning is about the work scope and sequence and tools and permits and all that sort of thing. Scheduling is about the priority and the resource allocation. So your planners are really focused on one set of issues and skills and so on, and your schedulers are focused on another. And you know, I think that's real important. I've been told, and Gary, you might know more about this than I do, that in large operations, maybe one scheduler for every 4 or 5 planners. Is that a reasonable ratio?
It is, but I also see one planner and one scheduler. That is quite common.
Okay.
One and one. But in the larger organizations, yeah, more planners than schedulers.
Okay. All right.
Yeah.
Now, let's see. I want to talk just briefly here about tool time, wrench time. You know, we call it wrench time. I think you guys call it tool time. I know the Aussies do. So, should you measure it or not? Is it important? Why should you care? Well, I think it is important, but if you mentioned this earlier, my view is that you measure it not so that you can see if people are working. You measure it so that you see what's stopping people from getting the work done. You're looking for the obstacles to their productivity. So if the permits aren't ready, if the parts aren't ready, if the equipment's not ready, then the tools aren't ready, all that sort of thing. So you're looking for the obstacles to their getting their work done, as opposed to looking for whether or not they're working so you can beat them with a club. And if you do that, they're going to be a whole lot more cooperative, collaborative, and so on with you, as opposed to if you're doing it and saying, damn it, you're not working very hard, are you? So any comments on that?
Well, I've seen numbers run around when work is performed without planning, that productivity is around the 25 to 30% mark.
Yeah.
Without a planning process in place, and that it increases substantially with planning and scheduling in
Well,
place.
I've seen it as low as 10%.
Really?
Yeah. That's up at, well, I better not say the site, but Andrew and I spent quite a bit of time up there with a utility company.
Yeah.
So, and it was because, there was no planning process at all. And so the guys waiting for a work order, waiting for parts, waiting for permits, waiting for one thing or another. And you just wind up spending 10% of your day actually working. That is doing the work that you were assigned to do. And the other 90% is dealing with all those obstacles to get your work done. So, now, a couple other points. There must be a link to the storeroom so you can put the work that's got planned into the storeroom, and the parts can be picked and pulled and set out for you in a particular location. Very often that's not done particularly well, and that improves, of course, productivity as well. And so that's one point. Any comments on that before I go on?
No, I agree with that point you've just made, Ron. Yeah, have your spares linked to the CMMS and to your plans, definitely.
And to your cost accounting.
Yeah.
And coordinated with production. It gets really, really complex really quickly,
Yeah.
And a lot of people think, just plan the work, go on, and it's not that simple because of the complexity of all the groups you have to interface with, and all the groups you have to interface with.
One thing, Ron, that I've seen that does work well is when you've got what I call a work management workflow, so that you've got a business process map that actually links everything together, and that becomes what I would call your single point of truth. This is how work management works on this facility, and having that map and having everybody understand where they fit in that map helps a work management process. I struggle to see how companies can do work management without an overall process map to support it.
Well, and you can't just create the map. The engineer or the planner sits and creates the map, and then that's it. It sits at his desk. You have to train the folks that are impacted in
Yes,
their role and how it all fits in and how it all works together, and then adapt it as appropriate to their particular issue or need.
that's right.
So
And,
it
and
has to be widely disseminated.
a step further than that is actually involve them in the creation of the
Yeah,
that
correct.
map, which I think is what you'd be alluding to, Gary.
Definitely. Yeah.
Yep. So, anyways, couple more points here. Doc Palmer suggests, and I argued with him at first, but I came to be a true believer, and that is schedule 100% of the workforce available, for the following week. And, my argument, of course, was what you typically hear is that, well, what if you're at 20, 30% reactive and that happens every week? Don't you want to hold back 20, 30%? And his answer was no, you do not. And the point being more psychological than anything, and that is if you schedule more work, people will expect to do more work and you'll get more work done. So there's a psychological impact there on folks. They're not just using that buffer as an excuse not to bother. They know, oh man, we got to get this stuff done. And he's demonstrated this works, time and again. And the second thing that happens, which may be as important, is you'll make better decisions about what work needs to actually break the schedule. Because you'll have to sit and think it through and say, well, yeah, we got redundancy there. We don't really need that back online this week.
Yeah.
That means you better have taken care of the backup.
Yeah.
So you may get burnt once or twice before you finally learn, but schedule 100% of the work, but allow for breaks to the schedule. You'll get more work done, you'll be more productive, and you'll make better decisions about what breaks into the schedule. So any comments on that, guys?
So just clarification. So you're saying every person that's available for next week who's not on holiday is fully scheduled with a maintenance activity or that. Would you also for shift maintenance teams, shift teams?
You'd schedule them.
You would schedule them as well.
Yep.
100% of their time as well included in that.
Yes. No,
yeah.
But again, allow for them to divert from that schedule, but you schedule them for things like routine PMs, things that require other resource like the machine repair shop or scaffolding or whatever. You wouldn't schedule them for that.
Correct.
But you would schedule PMs that they're going to do. If something comes up, they go take care of that if it's appropriate. And schedule all of it, And I think a lot of people have heartburn with that.
Yeah. But I think there is a really good consistency there with the OEE measure, because what you're saying is what is ideal for maintenance productivity, and you're managing against that level of ideal, and you've got consistency, and then you're looking to remove the blockers while you have the schedule breaks and why equipment doesn't get released on time from operations to get the work done. Whatever causes you not to achieve your planned goals for each week, you've got one measure that you can use to actually to drive improvements, highlight issues and drive improvements.
And kind of another psychological thing, if you do this, is this: if guys that you're probably never going to get 100%, and guys said, "Well, we failed." No, that's not how you manage this. Anything that's better than what you had is great.
Yeah.
Okay. So if you were at 70, now you're at 75. Yeah, you didn't get to 100. That's all right. Look what we did. We got 75. Or if you go from 75 to 80 to 80, you're looking for these incremental improvements as your measure of the success of the organization, not in achieving 100%. Because you probably never get to 100% consistently. If you get to 90, 95, man, you're doing great. And you ought to be rewarded for that and encouraged and all that sort of thing. So now one more comment, I think, and this is it. Winston Leday again. Winston's one of my favoriteest guys in the world. He just, came up with some just super duper stuff. And he says, maintenance planning without proper condition monitoring and defect elimination. So you're planning all your jobs, right? Uptime improved 0.5%. Wow. It's not very much, is it? Then he goes on further to say that doing condition monitoring, when you have poor planning and scheduling, uptime actually goes down because you've got resource dedicated to finding defects that nobody cares about.
Yeah.
And it's not doing anything about,
Yeah,
Yeah.
right. Well, they care, but they don't do anything. And then he says combining condition monitoring with planning and scheduling, uptime improved 5%. So now you're in positive territory. You've linked your condition monitoring to your work management and you get a benefit. The other two, you don't get anything. But the most important one, he says, focusing on defect elimination, that is eliminating the defects in the design, procurement, stores, operations, and maintenance, and having processes to identify and eliminate those, and engaging the workforce combined with condition monitoring and planning and scheduling. Uptime improved 15%. So that just highlights the importance of stopping the defects that create the work, having processes to detect the defects early so you can minimize their consequence. And so I think that's a really, object lesson for everybody to take away. So that's all I've got, guys. Any other, comments or remarks?
Go on,
I've
Andrew.
just got one question for you, Ron. Just going back to what you said at the very beginning, which is one of the things was that the maintenance plan and the production plan should be integrated to a single plan for a plant or for a site. Have you seen any plants that do that really well? Have you seen any examples of that?
Short answer is no. So I wish.
Okay.
So, and of course, the point being you don't want finger pointing. You want folks working together to address and adjust those. Now, I say no, but I suspect if the old Charlie Bailey example, where he held production responsible for reliability with maintenance and support, and they were both held accountable for unplanned downtime, maintenance and repair costs, and production schedule compliance. And that's where he got the cooperation. And you would suspect that necessarily those plans would have been combined, but I don't know that for a fact.
Yeah.
So
yeah.
And I also think, if I'm looking back, you and I, our experience in working with some of the companies over there, I suspect that, some of those companies actually had to do that, even though we're not specifically aware that they did. Okay. Otherwise they wouldn't have got the results they got.
Yeah. Yeah.
So the short answer is yes, but I can't confirm it because I didn't see it.
Yeah.
Okay. All right. Gary,
anything?
No, just one final thing for me from a good planning and scheduling process and using the CMMS is making sure from a reliability engineer's viewpoint is that I know you talk about collecting defect information and data, but definitely collecting failure codes and failure modes so that the reliability engineer can use that information proactively and that we can do some level of analysis to prevent failures in the future. So it is that defect management process. But how many organizations are not using failure coding as a compulsory or you've got to use that field in the CMMS? Quite often it's just left there as an optional field. And when you come to do the reliability analysis, you look at all of the work orders and you find that 80% of them have been the failure has been described as other or unknown, and we're not using the CMMS well enough to help with any future reliability analysis. So that would just be my final point, is from a reliability point of view, let's use the planning and scheduling to support the reliability engineers moving
And the
forward.
equipment histories. Yeah. Okay.
Yeah.
All right. Very
Good
good.
point.
Kim, are you out there?
Yes. Well, thank you
Okay.
guys so much for this awesome session. It was really great to hear y'all together and agreeing with, planning and scheduling and what needs to happen. And to our wonderful audience for listening too. We had some people joining in and just kind of listening and taking it back. And so hopefully they take this back to their teams and can improve a few things. Just a quick reminder, you can see past episodes of Connect Conversations on YouTube and reliabilityconnect.com. Be on the lookout as new episodes typically air every other Tuesday at 2 p.m. The next one coming up is Developing Reliability Partnerships for Reliability and Superior Business Performance. If you are interested in engaging with other industry professionals or would like to participate in the industry's live feed and forums on Mobius Connect, you can too at mobiusconnect.com. Thanks again for joining us. Stay safe. Please have a great rest of your week, and we will see you all next time.